So hi, my name's Ash. I'm a Droid, off to a great start, Android and Kotlin GDE in Berlin. And I'm going to be talking about idiomatic APIs and building them with Compose. Often I'll give this with a reflection on multi-platform, but here I'm mostly just going into the API design and what it means to be idiomatic, and sort of like giving a bit of a background behind all these words that we love to throw around that describes whether our APIs are deterministic, idiomatic, or however they're going to be, or reactive, or idempotent, or whatever. So on face value, what do we consider as an API? I mean, when somebody says the acronym to you, API, you might immediately think of, well, a web service, for example. I'm going to call the GitHub API and get some information about whatever resource I'm actually inquiring about. And that is essentially true. This is an application protocol interface that we're interacting with. And it's essentially just a way of communicating data with another program application, hopefully written by a human. They might also ask, like, what's the difference then between APIs and protocols, for example? Now, protocols you'll probably be familiar with as being mechanisms for communicating this information over the wire. So it might be encoded, serialized, or transcoded, or however. A lot of protocols exist already that you might be familiar with: SOAP, REST, GraphQL, or gRPC. These are all just different ways of communicating information over the wire. And in themselves, you could also kind of describe them as being APIs. They define a contract that is a way of communication between two parties. Then SDKs you might think as well. So you have people who are building SDKs are maybe perhaps building a tool set using the native language for consuming a RESTful API, for example. Common examples would be Firebase or Google services, where you're using an opinionated set of tools from the original developers on how they think it's best to use these APIs. The nice thing about these is they can be opinionated, and that they can convey a lot more information than the initial API documentation on its own. But they are themselves also APIs. What about ordinary code that you might be doing during your day job? You're just doing some very mundane things, introducing a new feature here, introducing some tests here. Well, this is also an API, because there is no scenario where you're going to be the only person, or there are no people actually going to be looking at your code. Whether it comes through API review, if it comes through like a new developer years later trying to decipher what tests you tried to write, or even if it's you in 2 weeks. You know, you come back off a holiday, I'm sure we've all been there, and you've completely forgotten how to code. Done that a few times, if only after the weekend. So I gave a lot of talk about this, and if you know me, you know that I always like to talk about APIs and what considerations should go into making them. And I gave this talk a few times, once at droidcon Berlin, right here actually, a couple of years ago, and that's me saying to you that I consider everything to be an API. And when you start thinking about everything being an API, you start thinking about, well, where is the boundary going to be between what I consider to be mundane or day-to-day code, or code that I would consider a bit more special or a bit more kind of thoughtful about, because I'm thinking about who this code is going to be reviewed by, who is going to see this code. So a lot of arguments you might get as well is like, well, it's just a unit test. I don't need to kind of worry too much about that. It's just kind of proving my logic. But it's a nice way to think about unit tests is that unit tests are still production code. It just doesn't ship, because this code is being written upon production code and it's verifying the outcome of it. So it's still going to be proving why it's there. And if you've ever had the unfortunate circumstance of having to refactor somebody else's tests, you'll often find it's quite frustrating to understand what on earth is going on, especially if you have the misfortune of that test being written by an AI. But of course, we've all been there. We've all been in that kind of crisis moment where you absolutely have to get a feature through before the code freeze ships or code freeze happens. Then you have to prepare for the next release or something, or it absolutely has to be done before Friday because the CEO really wants this feature being done because their daughter thought it was cool, whatever reason. But you absolutely have to get this done. So it's only temporary code. I'm going to follow up later. And whilst that may be true, I mean, you know, it never really happens, because the reality of things is there is nothing more permanent than a temporary solution. if you go and look through any code base, you'll find to-dos littered everywhere, saying like, oh yeah, this was just a fix to fix this random bug that happened in production, or some like weird messages about this thing. This is always going to be a situation where this is going to live longer than you or I or any of our children. I mean, it's all in this ICE vault as part of the GitHub archive, so it's going to be there forever. So consider who exactly your API is going to be for, because we've established now, and I hope you're all on board, that everything is an API. If we think about it fundamentally, what do we need to think about this? Who is going to be decoding this as what tools they have at their disposal, how experienced they're going to be, if it indeed is just going to be you in 2 weeks. So maybe you're an SDK developer and you're thinking about building a framework. You've got consumers to take into consideration. So these are likely going to be developers, and your product is XYZ. Say you're building a Firebase SDK, and you're thinking about how to convey this information and this guidance on how to use this API to your consumers. So you should be able to consider their requirements for that. If you're not shipping code publicly, then you've always got to consider your colleagues. You're going to have people who you're probably relying upon for peer review scrutiny to give your code reviews a thumbs up and get your code merged. And they are probably relying upon you as well. So it's generally a good idea to be a good citizen in your workplace, that you are giving people an easy PR to review. So if you think about things being easy to read, easy to understand, and having little cognitive overload, then it's going to make your colleagues' life a little bit easier, because you're going to get better, quicker PR reviews, and you can then repay that favor in kind. And as I alluded to a few times, there's always going to be a situation where you're coming back to your code yourself and thinking, what the bloody hell was I thinking? Or at least maybe that's just me. So obviously, there are going to be consequences of a poorly designed API. And you will probably already jump into the conclusion that, well, the consequences of a badly written API are that it costs me extra time, or it's hard to read, it's hard to understand. But there's some real-world consequences that are not just labeled as tech debt. For one, you got job security. If you write code so badly, then you're going to be the only one that can understand it, and you're going to have a job for life. But jokes aside, you're going to have an increased learning curve. So it's going to take a lot longer for people to understand what's going on in your code. And you might have new people on the team, even if they're just new developers. There might be new people on your team or on your project, even if they're experienced developers. It's still going to have that additional time necessary for people to learn how to do before people can be productive and start writing code that is going to be hopefully a feature or something that will hit your production app. As I alluded to, you're going to have longer peer review times. If you've got like 1,000 lines of code changed in a PR and it's really cryptic and difficult to read, ain't nobody got time for that, as the meme goes. So you're going to have fewer code reviews, and you're really going to have to kind of push people to kind of get their buy-in and get their approval, so you can actually get code merged and move on to the next task. So you want to make sure these kind of things are small and easy to read. Like I said, minimal cognitive overload. And essentially, the biggest argument that you can make about this, and why you shouldn't have tech debt, or why you shouldn't have this, or why you should pay more attention to APIs, is that it's going to slow your feature delivery. It's going to have a real-world fiscal impact on your ability to ship a product. It may affect your speed to market. It may affect your platform stability. But there is going to be real-world fiscal costs to this. And this is the important point to make. If you ever have to argue with a product manager who says, no, it needs to be done right now, or can't we come back to that later, or surely it's only a small 5-minute fix. There are real-world impacts. There's a quote from, I don't know how to say this properly, Jean-Paul Sartre. Every existing thing is born without reason, prolongs itself out of weakness, and dies by chance. There's a nice flip on this applied to writing in ANSI C, where every line of code is written without reason, maintained out of weakness, and deleted only by chance. And I love this phrase because it's so true, and it really kind of hits home in the way that we feel about code. Is that you don't really kind of feel a strong sense of connection with this code. You're like, it's just there, you're maintaining it. And that's the crucial point of this, is that from the second the code is committed and put into the repository, that has a maintenance cost. And this is different from tech debt. every piece of code has a maintenance cost. Now, compare this to painting a wall. If I don't take consideration to how the foundations are, if I don't put proper padding or insulation, or if I don't put proper the stuff you put before paint grounding, if you don't do this properly, then you're going to have a shitty wall. The same goes with every sort of level of craftsmanship and any sort of thing that is going to present itself in the same different way. If you don't take consideration to how the system is already operating, if you don't take consideration to who's going to be building this API, who's going to be working on this, who's going to be maintaining it, who's going to be owning it, then you're probably going to end up with a shitty product. So thinking about that, what kind of good things can we think about, about APIs? And the term is often used idioms. So this talk is called Idiomatic APIs, so I must eventually get onto the topic of idioms. If you're familiar with idioms as part of the spoken language, it's a very familiar phrase. So things like break a leg, bite the bullet, have your cake and eat it too, very popular amongst the British people. These are phrases that are used so colloquially that they have become ubiquitous. They are obvious what they mean. People understand it. Even though the words don't actually allude to what they actually mean, everyone understands what break a leg means. I'm not wishing you to actually break your leg. I'm wishing you luck. And these exist in every language, but they don't translate very well. If you say it's raining cats and dogs in German, it just sounds weird. I'm not going to try and translate it. My German's not good enough. So es regnet Katzen und Hunden. Yeah, fair enough. So idioms exist in every language, and that includes programming languages. When idioms are used to express pieces of code or styles in Kotlin, for example, these are features of the language that we can use to our advantage to reduce the amount of boilerplate, make things more concise, or basically using familiarisms that are familiar to the code that communicate what we need out of this outcome, and it's very easy to understand because they're consistent with the design of the language. So for example, you have default parameters where you can order things, and up until I think 1.6 you would only be able to do ordered parameters, but now you can actually mix and match. This allows you to cut down a lot of boilerplate code when you have operator overloads or things like that from the Java land, whereas in Kotlin you can have this as quite simple. Very important when it comes to compose as well. You have the deferring of computationally expensive lazy properties. So actually what's going on under the hood is quite complicated. If you've ever dug into how Dagger produces its providers and with this double check lazy and single check lazy and having all this thread safe operations, it's actually not so straightforward. But in Kotlin, it's just a simple lazy property. But this is an idiom of Kotlin. People understand what this means. And then our favorite thing, null coalescence, or as everyone refers to it, the Elvis operator, the way we can avoid all these kind of complicated if checks and statements and things, and you can understand what's going on because it's familiar to Kotlin. Oh, yeah, this one is a fairly recent one, actually. You can now include return as a part of your expression statement. Before, this was not actually allowed because it could not be accurately defined what your return type is. But now this can be done, so it's quite a nice thing. And another new one that's been introduced recently as well is guard conditions in your when clauses. This allows you to kind of collapse a lot of your complex logic, and it makes it a little bit easier to read. In addition to all these idioms, then I only covered a very, very small handful of them. There's a large number of coding conventions documented on the Kotlin Lang website as well. And sort of reading up on these conventions and being familiar with this idiomatic code allows you to create APIs which are kind of really easy to understand, or much, much easier to understand. So of course, the idioms largely revolve around the language itself, so there are going to be different idioms for different languages, but of course, I'm going to be focusing here on Kotlin, as I hope everyone is interested in Android development or otherwise, unless you use Swift, maybe. I don't know, maybe. And it can be a little bit challenging to keep up with all the latest features because Kotlin is kind of like an aggressively developed language. It's under active maintenance and active development, which is frankly really refreshing. If you ever had to live through the days of running Java 7 code on Android, that was not fun. We came up with all these kind of weird hacks and solutions to try and get around this problem of not being able to enjoy new language features on Android. So we had retro lambda and auto value classes and all these different libraries we used to use. Whereas now this is kind of built into the language, and it's kind of a de facto idiom of this language that we can understand. So it's a short timeline, or very abridged timeline of Kotlin features. So it's really worthwhile kind of reading the release notes every new Kotlin release. I believe that language features are introduced in 0.0 releases and tooling in 0.2 as of Kotlin 2. So that's interesting to keep up with. And one particular overhaul of the language I like to kind of cover as well is coroutines, and again, later Compose, which I'll come on to in a minute, because it sort of had a very impressive paradigm shift in Android. So historically, we used to work with XML layouts and have everything was reactive, RxJava everywhere, or all these different things. And we had this kind of revolution of what was reactive code. Now, typically, in the old days, you'd have this horrible kind of imperative-style syntaxes where things are just define, like one line after the other. Whereas reactive kind of allows you to observe various different sources. And this became really important when you started to consider different input sources, things like you might have an on-device cache, you might have a backend server, or you might have like some paging or database services acting on device. And when you have to kind of coalesce all these different input streams, you had to be able to observe this in a whole kind of change. So we went absolutely RX crazy and put streams everywhere. Yeah, here's an example of some old-style imperative code. It's our favorite async task. Can never seem to move on from this horrific nightmare. But it's really unclear what's going on there because, well, it's shit. Excuse my French. So we moved along from that to using RX-heavy or reactive kind of code. And it reduced a lot of this old, hideous imperative logic with a lot of new, hideous logic. And introduced this concept of RX where it's like really difficult to understand what on earth each one of these operators is doing. And you'd have to have a lot of experience with RX as a specific library to actually say what's going on here. And this actual operation is doing something very, very simple. It's actually just doing hey after a few seconds repeatedly. So it's burying the actual important information in the sea of noise. It's not helpful. It's increasing your cognitive load to a massive threshold, and you kind of require intimate knowledge of how this framework is working to even understand what the hell is going on. This is why coroutines was actually a really nice introduction to Kotlin as a language, because it introduces the concept of structured concurrency. And utilizing features like DSL constructs and building language-specific domains in your Kotlin code meant that we could introduce, as I said, structured concurrency in a way that was inherently obvious to how you're building your code. Your scopes are handled inside an actual Lambda. You can be sure that everything's being cleaned up afterwards if you're doing things correctly, of course. And this introduced a lot of niceties that we now see in the Kotlin language. But it also slowly introduced this kind of concept of declarative architectural patterns. This is code where it's sort of like it's more focused on the why instead of the how. In imperative languages, you might have like, do this, do this, do this, do this. And then with declarative architecture, you're more describing like, why it should be or what it is you're actually trying to do from a domain perspective. So it's a little bit easier to read and reason about rather than, oh, I'm adding some text to a text field. And one of the core tenets about this is the concept of immutability. Now, you're probably familiar with immutability, but it really goes quite deep. I'm not sure if that's a pun. Is that a pun? But the point is that assigned objects cannot be changed. We have immutability in a lot of kind of simple things. Even the string itself is an immutable instance. But by making sure that things cannot change under the hood, then you've got this kind of level of predictability. You can be sure that at this time, this object equals this. And that means you can then have all these instances where you've got like an event, a sequence of event emissions, and you can replay these, and you can see how things have been interacting with each other. This is very popular amongst Redux and Redux-style architectures. But kind of went a bit overboard with the reducers. It also introduces this concept of idempotency. For a very long time, I was not able to say this word properly. Idempotency, it's quite hard. But you can just think of it as deterministic programming. And this is basically that you have a pure function. If you have a function that takes an input and gives you an output, it can be replayed as many times as necessary, or as many times as you want, and will always give you the same outcome. This level of predictability, this determinism, is essential to how we work with modern applications. And it's essential for us to how to be able to reason about the system, because it makes it predictable, it makes it reliable. We can rely upon what's going to happen next, or ideally. And that's where it introduces the concept of unidirectional data flow as well. You probably heard this from modern Android development, from pretty much any recommendation about architecture, is that you have a unidirectional data flow. The explanation is exactly what it is. It's the unidirectional flow of data. So you're not having things going bidirectionally, and you can then, it makes it easy to reason about where the source of truth is coming from. If you've got multiple sources of truths, you can't be kind of sure what state your application is in, or it can be considered a Franken state, because it's like a mishmash of different parts and things. So you need to be able to kind of rely upon where the source of truth is coming from. So this is where I want to bring into the concept of compose as well, because coroutines was a massive shift in the way that we build asynchronous code. With a lot of stuff going on in the hood, it becomes a bit more easier to read. Compose did this a lot of stuff initially with UI, so mostly initially falling under the Android X umbrella. The Android X team collaborated with JetBrains to work on the Kotlin compiler plugin API, so that they could then, in compile time, adjust your signatures, so then they can achieve the same kind of scope behavior. Many parts later added to the Kotlin repository, and now we have the Kotlin Compose compiler plugin, which is super nice. So Compose leans into this hierarchical tree node structure and allows for structured scope manipulation. So you have these trees of nodes, and you can sort of determine, given the input and the output of which node, what has changed, what needs to be re-rendered, or what can be considered dirty. And it does this through very clever compiler rewrites of your code, and it injects this composer parameter. And then, by starting and restarting groups, starting and ending groups, it creates this kind of concept of similar to structured hierarchy from coroutines, but in a way that can be restarted on a Compose UI level. So then you can kind of calculate if something needs to be recomposed because it's dirty, and only recompose the parts that are necessary. That's one of the fundamental topics of Compose. I'm not going to go too deep under the hood because it's confusing. But it's, I really recommend going into one of these deep dive talks into how Compose works under the hood. Very interesting stuff. But there are a lot of features. So there are a lot of features and idioms from Kotlin that Compose makes full advantage of, and that is higher order functions. Higher order functions are functions that take other functions as parameters. So you have these composable slot APIs, which are a really kind of fundamental part of how Compose introduces these idioms into your code, and how you can sort of rethink how you're building your code as you would be compared to just having a non-compose app. Allows you to avoid these rigid method signatures, so a lot more flexibility in the way it does it. Also using a lot of scopes. I was never really sure if it was actually recommended practice or not until, well, actually, I'm still not sure. But the concept of scopes is introduced with Compose, where you might have inside of a closure the scope that allows you to give more information or more behavior out of the operation of the Lambda that you're currently in. There's a good example here with weights. So only if you're in a scope that supports it, so if you're in like a column or a row or a lazy column, lazy row, that will give you access to this kind of weight structure, because it only makes sense in this context. If you've got like a box on its own, well, the weight doesn't mean anything because you're not comparing it to anything else. So it makes sense for it to only be available in that scope. And this is employed with a lot of different aspects as well. You can also create your own scopes and extend upon this. But like anything, it can be abused, so don't go overkill. But good to use when you've got layout-style calculations necessary. You've also got this on the top app bar, which is telling us these actions are going to be rendered in a row. So it's giving this information about row scope, saying that this is going to be in a row, so you can be sure about this. You don't have to put your own row there. You don't have to make it adjusted or anything like that. So Yeah, as you can see here. So you can be sure that these two will be rendered in sequence in a row rather than in a column, or making some vague assumptions. Like, I'm looking at this code, and I'm seeing by the use of these idioms and the API that this is how it's going to behave. And this is added into the predictability and the determinism of the application. There's also a lot of use of property delegates. You might be familiar with this if you've used this remember mutable state of. This means, because Compose is obviously a very complex architecture under the hood, there's some more complex objects necessary than just simply having a value assigned. So having these property delegates means that you can do some very creative things with how you're retrieving the object from that instance. And this instance can be like a manager or kind of controller of state. So. And here's a cat. So traditionally, when I said about coroutines introducing a lot of simplification about how we handle asynchronous logic, we took that and thought, wait, I can do one-shot operations, but I need to make it reactive again. So we had all the same problems that we had with RX, and now we have them in coroutines as well. Well, one of the nice things about Compose, and I've covered this in a couple of different talks as well, is that it allows you to kind of use this Lambda-style scope logic in a way that kind of restructure your code, so you can have sort of sequential operations, even though it is actually doing things in a scope. Because remember that Compose is just a tree of nodes. This tree of nodes can be anything. It doesn't necessarily have to be part of the UI. But we can have something like this instead. And here's another cat. So we're having like our declarations in sequence, so we can clearly see like, oh, this is a variable, this is a variable. And Compose is clever enough to be able to recompose things as necessary when something becomes invalid. If that value changes, then it will then recompose the necessary parts that it needs to. And this allows us to kind of make much simpler APIs in Compose than we would do otherwise. There's a great example of this as well with Molecule. So the folks at Cash App built Molecule to be able to use Compose to render your to build your presentation logic. So there's no UI there at all. You're just kind of using this Compose logic to kind of collect state and have kind of sequential statements. And I'm going to do a bit more talk about this on my website, about the talk Beyond the UI. This is at MDEV Prague this year. And so fundamentally, like these idioms and the way you use languages are really important. And so I want to take a bit of a sidetrack here as well about language and the use of language in APIs. So language is super, super important. But obviously, with spoken languages, we have like over 7,000 different languages being spoken with different dialects and hundreds of different thousands of ways of saying hello, and thousands of different ways of communicating about programming and languages. So with all these different languages available, how do we decide which one is the most predominant? Which one should we use with our programming? Well, thankfully, the Americans gave us theirs. So with the initial development of a lot of the world's first programming languages, these were done by very clever American and English-speaking mathematicians and scientists. Most famously, Grace Hopper, arguably the mother of modern programming languages, came up with a precursor to COBOL, I think. And this means that to this day, I simply have to bite my teeth and bear it. Because every time I introduce color as an alias to an import, I get shot down. But damn it, I'll try. So the average European speaks 2 or more languages. And this is not even to go into consideration about business-specific terminology. I hope this joke would land better, damn it. So yeah, a lot of Europeans speak 2 to 3 languages, except for some obvious outliers. The UK people, it's at the bottom. So it's not uncommon for these kind of different words from different languages kind of sort of creep into our code base. And this happens quite often. If you've got like a multilingual team, you might be introducing kind of different words into English phrases, and it's a kind of a headfuck. I mean, I don't want to be the English-speaking guy coming to Germany saying how you should write your APIs and not use your own mother tongue, but it is a bit of a jarring experience to read code that is in more than one language. But there's always the option of a German programming languages. There's a Teuton, which is a German port of Python. So, just saying, it's out there. Actually, a little bit of research into this. There's a surprisingly large amount of multilingual programming languages that revolve around, like, obviously the native-speaking dialect, but it's fascinating, like, how many exist. But going into business-specific terminology, so you'll find there's a lot of things about your domain that kind of these terminologies, these acronyms and words and things that make sense in the domain perspective that kind of creep into the code base. And they may or may not be helpful in some circumstances, but they can sometimes add confusion. I'm not saying don't use these business-specific terminologies because it can make sense for your product, but just be concerned or have the concern that it might not be immediately understood. You can always sometimes provide a glossary or some sort of helpful documentation on what acronyms mean in the domain sense. But if you've got a new person joining the team, they might be a bit confused as to what all these weird little acronyms mean. And here's the joke at the expense of droidcon, that you might find these words quite common in their code base. But cross-language domain terminology is actually a really specific problem, and it does actually happen. And I don't have an immediate answer for it, because I shouldn't say you should only write code in English, or you should only write code in French or in German or whatever language you're speaking. Just have that kind of concern about, OK, who's going to be reading my API? Who's going to be understanding this? Is it going to be a native English-speaking person? Is it going to be a native German-speaking person? Is lingua franca of the company this or this? So just have this kind of thoughts about where this is going, and make best use of your time so that your API design reflects your business. So thinking about all the bad things about APIs, what could you say are good things about APIs? So API design is a very complex topic. You'll often get different opinions based upon who you ask. One person will say one thing is great, one thing is terrible. And that's very subjective, because we're talking about communication here. This is what people understand and read from your code. These are ever-evolving language constructs. So I think it's important to think that there is no such thing as perfect code. Code is an expression or intent of communication. So the most important thing is how much you understand from this code. It doesn't matter if it's right or wrong. If you understand it, that makes it right. I'm going to regret saying that. You can also, or if you're at least like me, fall into the problem of the perfect solution fallacy, where you believe that there has to be the perfect solution. You keep on refactoring and improving and spending so much time on trying to get things perfect, and then come back 2 weeks later and it's like, why did I spend time on that? But this especially falls into the fear if you're an API maintainer, for example. As I mentioned earlier about the cost of maintenance, all code has cost maintenance. It can be natural for you to be a little bit fearful of what monsters you might introduce. If you then write an API that then gets consumed by people, well, then you're going to have to maintain that API until the end of time. And that's not going to be a fun thing to do, because you're going to be constantly reminded of what better decisions you could have made, or different directions you could have gone in, or, oh, God, this was using an old technology that I hate now and should be destroyed. So the trick is to keep things small. Keep your API surface as small as possible, so then you have fewer chances for mistakes. Ideally, 0 is the golden number. You may seek to provide documentation. Documentation might be seen as a good approach to provide additional context about your API, about what it's doing. But you'll often find that documentation expires quicker than your code. It's noise-heavy, can often be out of date, and in some cases, actually, documentation can be misleading about the true nature of the code and what's going on. So none of this documentation here is actually giving me any information about what this class is actually doing. I mean, it's a generic class, and it's fairly trivial, and so I can't really reason about any behavior that it actually has, but the documentation makes it a little bit more confusing as like, well, is there more going on here, or is it simply just a class that says it's a group? So ultimately, I like to come to the conclusion that good code is code that is easy to delete. It is well modularized, it is highly cohesive, it is loosely coupled, it is all the nice things we call about APIs, but most importantly, it is easy to delete, because there will come a time, I guarantee you, where you have to come back to this code and think, oh, this was a mistake, or oh, I wish I did this a different way, because now I have to have this new feature that I didn't know about. And it's going to be much easier for you to destroy a piece of code, and a lot more fun, than it is to try and figure out how to change your code for those the new requirements. So as I mentioned, high cohesion, loose coupling. High cohesion is when things individually work well as a unit, as a collective whole. And loose coupling is that things can be easily replaced or swapped out. Think of like the opposite of a modern phone, where you can change parts easily, which you can't with a Pixel. And a very important way of managing this is dependency control. And you might have heard this through lots of different kind of principles and solid design principles and all these different things. And if these kind of principles work for you, then go for it. It's great. But ultimately, you just have to think about dependency control, making sure that your concretions are hidden behind fine-grained interfaces, that your third-party APIs are not leaking through your implementations, and that your implementations are injected with only the dependencies that they need and only the requirements of those interfaces that they need. So don't inject context or any other God class, for example. Only inject the class that has the behavior that you actually need for that thing to do. And ultimately, as well, we have tooling. Tooling is a big part of our engineering process. I have a lot of automation going on as well. And it can work well to sort of quash any bike shedding arguments that you might have if everyone's arguing, like, should this be named this, should this be named this, should it be uppercase, lowercase, snake case, screaming snake case, whatever the case. You can have this automated so that it no longer becomes an argument. It's like, oh, it is so the tool says. And some nice implementations of this, for example, there's explicit API mode, which you can enable in Kotlin. I very much recommend doing so, even if you're not producing an SDK. But this forces the use of explicit public and internal declarations when you're creating classes and things that might be used across modules. Because Kotlin classes are, by default, public. A mistake, in my opinion. But yeah, being forced into making these declarations explicitly gives you consideration like, oh, does it need to be public? Can I make it internal for now and then expose it later on? And then maybe you only need to expose a small part of this behavior so that you create an interface and you move along for this. This constant vigilance over what needs to be visible allows us to kind of have a better policing of our APIs. Of course, there's lint checks as well. What would we be doing if I didn't mention this? You can use the linting CLI from Slack. This was originally maintained by Twitter, rest in peace, but now maintained by Slack. And there's also this from I can't remember the name, Lopez. But this is for KT-lint and detect. And these allow you to kind of get rid of any of these bike shedding conversations about how or why code should be so. And a lot of time, if you're rushing as well, you might be inclined to suppress one warning. It's like, oh, my method has 14 arguments, and lint is complaining that it should be a smaller class. And it is tempting, I know, to just suppress this and move on because you've got to get your work done by the end of the day, or you've got to meet a deadline, or the feature code, the code freeze is happening in 20 minutes. But these warnings are given to you for a reason. There's a reason that this lint warning is kind of giving you this warning. Maybe think about what you can do differently, or if it's possible or feasible for you to actually make some changes in the code. Quite often, you can actually resolve these things with a little bit of a refactor. So before jumping straight to suppressing a lint violation, think about how you can fix it, or be creative. Unless it's this one. Fuck this one. I don't know who thought this was a good idea, but it's one of my most disliked lint rules. So depending on how much time we had left, I wanted to open this up a little bit. So what makes a bad API? I mean, we must all have grievances about one example that was in our project or something. So I'm going to do, with what time we have left, I'm going to do a quick Q&A. And yeah, please tell me your worst API decisions or experiences, and we can all just have a collective group therapy session about that. Yeah, so now it's open. Thank you.